Let's use as an example a circuit where we have a resistor, an inductor, and a capacitor that are all in parallel. And we'd like to find out the amplitude and the phase of an incoming current. Now, what we know here is that three elements in parallel, the admittance adds. So this is YR plus YL plus YC. And if you recall, this is 1 over R. The admittance for the inductor is minus I over omega L. And the admittance for the capacitor is I omega C. So we have our complex number and our real number. And its magnitude is 1 over R squared plus this imaginary number, which is omega C minus 1, the imaginary part of it, squared to the 1/2. That's the amplitude. And the phase, delta, is just given by the imaginary part over the real part. So that is inverse tangent of omega C minus 1 over omega L divided by 1 over R. So let's just write it like that. Now, to analyze the current, we're going to use the relationship that the current is equal to the equivalent impedance times the voltage. And just to show you how we do these calculations, we have I naught, oscillatory part, phase, is equal to amplitude, phase, times V naught, e to the I omega t. And once again, when we cancel out the oscillatory parts, the amplitudes must be equal. So we have the very simple relationship that I naught is the magnitude of the admittance times V naught. And the magnitude of that admittance is given by this expression R squared plus omega C minus 1 over omega L, quantity squared to the 1/2. Now the phase is a little bit different than before. In order to cancel the two phases, you see that phi has to be minus delta. Then the two phases will cancel. And so the phase is minus delta, which is minus the inverse tangent of omega C minus 1 over omega L times R. And so we've now solved for the current that comes from the voltage source. It's a little bit different now to analyze the current in each branch, but one could do a similar analysis. The current in branch, say, I1 is equal to the admittance in I1 times the voltage across it. And one can carry out the same type of analysis for the current I2 is voltage across, is the admittance across the inductor, the admittance of the inductor with the current. And similarly, I3 is equal to admittance Y3 times V. And once again, that's a nice exercise for you to work out the details.